Hello, my name's Jared. You can call me Jardo. And we're back doing more Advent of Code stuff today. As you can see, Roxy's walking around behind me. I had a hockey game, the second furthest rink that I play at from my house, at 10:40 p.m. last night. So I'm going to be honest, I'm a little tired. Hopefully that doesn't prevent me from solving these problems. I think we're on day 10 today. I'm just committing day 9 part 2 because I've not done that. And I guess we can get into it. Oh, that's my YouTube. Where are we? What's happening? All right, so we're 4 puzzles behind. I'll probably stream today, tomorrow, and the next day to try and catch up. Hopefully at least one of these puzzles lined up here is relatively easy. But if not, we'll do our best. You all arrive at the lava production facility on a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. You're about to ask how you can help. As you're about to ask how you can help, the reindeer brings you a blank topographic map of the surrounding area, your puzzle input, and looks up at you excitedly. Perhaps you can fill in the missing hiking trails. The topographic map indicates the height of each position using a scale from 0 to 9, for example. And we see an example. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0 and ends at height 9 and always increases by a height of exactly 1 at each step. Hiking trails never include diagonal steps, only up, down, left, right from the perspective of the map. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. Trailhead is any position that starts one or more hiking trails. Here, these positions will always have height 0. Assembling more fragments of pages, you establish that a trailhead score is the number of 9 height positions reachable from that trailhead via a hiking trail. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9, the one in the bottom left. This trailhead has a score of 2. The positions marked dot are impassable tiles. To simplify these examples, they do not appear in your actual topographical map. This trailhead has a score of 4 because every 9 is reachable via hiking trail except the one immediately to the left of the trailhead. Sure, I can see how that's the case. This topographic map contains 2 trailheads. The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Yeah, I see how that is. And then they have a larger example, which has 9 trailheads. Considering the trailheads in reading order, they have a whole bunch of scores. Add these together, and the sum of the scores of all trailheads is 36. The reindeer gleefully carries over a protractor and adds it to the pile. What is the sum of all trailheads on your topographic map? All right, I'm thinking. Sadly, yet again, well, this is Valid Ruby. I'm still looking for a puzzle whose input is Valid Ruby so that I can do something terrible with it. But today we will not be doing something terrible. We will copy template and touch day10.text and open. Oh yeah, that means that it won't be in order. I guess I should have put the zeros in, but it's a problem for another day. So what I'm thinking about here is I think we can pick a trailhead. Pick or like I'm trying to think about this. So we can look at each trailhead and we can look at its neighbors and be like, okay, you know, which of these can reach a trailhead, right? Like which of these are valid steps backwards. And what I'm thinking is we make a map where of like our own map of this map where that stores the number of peaks, we'll call them, not nines, reachable from that tile. That's my immediate thought. I'm just trying to think through the algorithm for that, though. I guess that works, right? We start the nines, we grab all of the eights adjacent to them, and mark those as being able to reach the number of nines that they're touching. And then we grab all the sevens and mark those as being able to reach the number of eights that they're, or the sum of all of the 8 tiles that they're touching. That makes sense to me. So I guess that's the immediate approach. I can read lines, chomp, chomp, true, each. So we're just going to process our input out the gate here. Or I guess we want to map them. This is each with. Do we want the indexes? Do we care about this? It's not for now. Boy, am I tired. I also gave up. I haven't had any coffee. I gave up coffee today. Just to make my day make this even harder. So this is the line. And we want to split the line just on, or I guess we can do chars. I think that returns an array. Sure. Let's call that a starting point. looks cool. And if we input a transpose, then we get something easily indexable. Real quick, yeah. All right. So I don't know. Do we want to make a map class or something? I guess we briefly looked in the one day, but I had the matrix class. So let's take a look at that. If I can stay awake. This only uses numbers, integers in our matrices. That's not an actual like limit. Can I make like a matrix with whatever I want in it? I assume I can. How do I get this thing? Looks like it's in the standard library. It looks like it's in matrix.rb. What am I missing here? Cannot load file. Is it removed or something? Looks still there to me. What am I missing? What? Why is... I mean, I can do it myself, but... Certainly looks like it's there. Why wouldn't I just be able to require it? Matrix, yeah. Oh, let's to install it. I shouldn't need to do that. I don't know what I'm missing. But let's. Whoops, this is not what I need. I guess. Okay. So, seems perfectly happy with me putting whatever I want in here. In that case, we don't need to think about transpose or anything. We can just map equals matrix input. Lovely. Now we have a map. Lovely. I wish there was like a yeah, that doesn't. Just give me that back. Nice way to print them, but I guess not. Okay. Dog struggling to get comfy next to me. There's a couch like immediately to my left here. Matrix, and we want to make a new matrix, and this one we want to be the same size as our original matrix. So we can just back out and yeah. I guess it's the same thing. It was just a different new UI. Yeah, that's why I can't try and do this one. I'm tired. Build a matrix of size row count. X count fills the values of the given block, passing the current row and column. Okay, that's easy. So I assume this gives me a what is it, row count? Yeah, row count, column count are the methods. So I can make a new one that's the same size as my old one. I can say I don't know what we call this. Paths, sure. Or path map. I'm just calling it paths. That's I'm gonna regret that. I'm calling it path map. Matrix. Was it .new? Was I just looking at the regular constructor? Is that what I was looking at? .build. And that takes map row count, map column count. I think. Sure. And fill it with nils. Or we can even pre-populate. No, it doesn't matter. Okay, so we have these two things. Now we need to iterate over certain values. So we need to iterate across the numbers 9 down to 0, right? Each do, and still haven't fixed that issue with my editor. Maybe applying this update will fix it. Oh, surprise, surprise, it didn't. Oh, maybe it did? I didn't do it there. Very strange. Well, it seems to be doing it less, so I guess that's a win. Guess we look at the API for this thing. Can we get element alias for? Okay, that's not what we need. We need more like a find or a index. Turn the index as row column. It also accepts an optional selector. I need multiple indexes though. That's not quite it. Orthogonal, no, we don't need any of these mathy things. I just want to call like find on it. Find index. But I need multiple indexes. This thing is enumerable, I think. That doesn't necessarily help me. Collect. The iteration of the given block over all elements yields all elements. Passing an argument. Straight upper yields. guess my question is, does something like collect, I guess we can play with it. Let's play around in the debugger. So we have our value n. We have our value n. Oh, shoot. We have our value n. That's also the debugger command, which is now 8. And we have our map, and we want to find all of the iterate over all of the indexes of 9s in here. Oh, and these are integers, which doesn't actually matter to us. Or so these are strings, but not integers, which doesn't actually matter to us, but we should probably fix that. Collect x, y, z. I want to see what the arguments are. Just the, okay. I can't like each with index dot collect. Oh no, what happened? Oh, this was, oh, that did work. This appears to have worked. All right, awesome. But we kind of want to select and map, right? I guess. Oh, let's see. What are the elements if? No, this is why is it a bunch of nils? What does collect do again? Collect is, oh, it's map. Right. Okay. That's fine. I'm just gonna call it map. Well, maybe we do call it collect since map means something else in this context. Boy, am I tired today. But we probably just want to select the ones for which x is equal to 9, right? Sure. That works. Map dot each with index select, and oh, we want to say chars dot map to I over here so we can compare these things without having to do a bunch of annoying stuff. And we select the, don't care about that, x and y. Oh, we do care about that. And we want to make sure that c equals n. I don't know why I call that c. Each do no, didn't, okay, so it didn't fix anything with my editor. Well, I mean, for the 9, we want to just mark these as 1s in the path map. Path map. Oh, interesting. X, y equals 1. So I don't think we do that there, because I think we do that here. And we say map xy is equal to 9, then 1, otherwise no. And that way we can skip 9 on this pass and do our regular logic, our non-special case logic. This is an interesting one. So now we have our map with 1s where the 9s are, just to say that those tiles can reach. So we're actually iterating over we're iterating over all of the 8s, and we want to count all of the 9s that are adjacent to them and put that in the value, right? So this is, so we actually don't need C there. We want to say, so what happens if we out of bounds this thing? We tested that yet? Path map 1,000, whatever. That's 10,000 and a larger number. So that gets nil. And what if we go off the? Actually, let's use map, because then. So that's not the behavior we want. But fortunately, we know how to use refinements. So let's refine map. And change the behavior so that it doesn't support negative indexing. Why is this not syntax highlighting? Oh, there's a do on refine blocks. Okay. So if x is less than 1 or y is less than 1, then we're just returning null. Otherwise, we return whatever we would normally return. Okay. All right, so then let's test again. Now our maps return nil if we go too low, and if we go too high, which is fine. I wish you could provide like a default value. We could do that. We could hack that into matrix. I don't really think we need to. So we want to set it to be equal to the result of summing path map x plus 1y path map or in fact we can just iterate over the coordinates. We don't have to duplicate all this logic. So that's the one to the right of it, the one to the left of it, the one above it, and the one below it. And then we sum these class x2, y2, and this is path map x2, y2, or 0. This should make us something, right? No. So okay, I'm missing logic. Right. I knew this was too. Oh, hey Marco, I didn't see you. Yeah, we're using matrix. So we only care about these if, so if map x2, y2 is one more than is whatever it is here, c plus 1. Then we set it, else, or so then it's value. Okay, that I think is maybe what we're looking for. Yeah, matrix and refinements. And as I mentioned this at the start of the video, but I played a hockey game at 10:40 p.m. at the arena, the second furthest arena from my house that I ever play at. So I am very tired right now. All right, so we see some numbers. I don't know if these are right, but they could be. Yeah, we use refinements to make it so that we can't negative index our matrices, so we just get nil if we go off the edges of them. So we want to do basically what we did before. Oh, we did not win. They stopped putting our opponent's goals up on the boards because they scored so many. It was really bad. It was our worst game yet this season. Our opponents were basically scoring at will. It was tough. So we grab the our 0 points, and we want to sum up the number of locations they can reach. All right. So C we don't care about here. We care about X and Y because we need to add up path map X, Y. And nil can't be quotient into it, which is interesting. How would we get nils? We shouldn't have any nils. I don't know how we've gotten nils in here. Path map does have nils in it. Well, the second position is a nil. It's a 9. That's not nil though. That should definitely be 1. Because this right here okay, well, let's examine it right after that. It should have already, that should already be set right now, but it's not. What is set to nil here? I wish I could print these out nicer. The first row has no 1s in it. Second one has 1 in the 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18th position. It's right here. It's a 9. It is a 9. Why is this 9 not getting set to 1? And actually, now that we look at this, the end of the second column is also a 9, and that's working. Then why Why is that 9 not set to... What is going on? I guess maybe we should be looking at our original map. There's 9 right there, as expected. 9's in all those positions. But path maps, first one is nil. Why would that be? I mean, I guess it's easy enough to put a binding dot break in here and see what we get. So this is x, y, right? Oh, x, y, 0, 0, yeah. And so we expect this to be no. I just like C, yes. And then this x, y. What the heck? 0, 1, nil. What? No, it's not. This. Oh, wait, did I mess up? Oh, I put less than 1. This is why I said I'm very tired. I'm writing. That's really terrible. That's funny. All right. Oh, okay. Continue. Oh, I don't need to do this. I'm just gonna exit and remove these. Hey, we got a number. Hope our approach worked, because I feel like my brain's not ready to think through a different one. Oh, it's too high. Okay. All right. I feel like we might need to give ourselves a way to visualize this. It's true, but it does penalize you and make you wait between attempts at guessing it. So you can't just binary search for the solution. What am I doing here? I guess looking at the map. Well, part 1, that's what I want to look at. I want a path map. There are really big numbers in here. How many 9s are there even in this map? Didn't copy paste it. So there are 131. So if we look at our path map, these are plausible. These numbers don't look unrealistic. A lot of 1s on here, though, and so few 0s. Which interests me. I think I want to write the code to make it so we can visualize these things. And that way we'll have some kind of, we will be able to step through looking at it. A There are no 3-digit numbers in here, so actually that makes it not too hard. can even write the method here. So I think we're just gonna put this in a here doc with some interpolation. And I'm just gonna, don't want to do that. How do I want to do this? How do I iterate over the rows of this thing? Probably rows. Row, that gives me an individual row. I want an iterator for rows. Chance factor of I, the matrix, that's not what we want. Row vectors, sure. I can work with row vectors. So I guess I don't even need this, do I? It's row vectors dot map row, and each one of these is going to need to be a I want to format them so they're easy to read. How do I pad numbers? Ruby left pad number spaces. Yeah, or pad string, sure. Ljust, yep, that's what I need. So then row.map, so now we're wrapping the individual values. Yeah, Ljust, it's not the most memorable. Value 2s, actually value or dot 2s, Ljust 3 space or 2 space, and join these with spaces, and then add a new line on the end. So I want a new line on all of them. I don't know. Oh, and then join. Oh, sorry, map value. Oh, then this is supposed to be out here, and then this is a join, just regular. Something like that. Join should go after the. Okay. Did I do it right? Well, that didn't work. Okay, I did something wrong. Value. Okay, sure. Undefined method join for an instance of vector. 2a. Cool. Now it looks. This is interesting. It's cool. It's cool that this works. So now we can, rather than stopping there, at each, we can put path map dot inspect finding dot break, and then we can do that after every step to watch this fill out. So our first one should have, can we zoom? Okay, apologies if that is kind of small, but I want to be able to see both of them at once. We can see that our 9s are correctly marked as 1s. So we'll continue. This all looks right. Oh, we have a 2 somewhere down here in this column. So we've identified that what's going on here. Oh yeah, so this one in the middle can in fact reach 2. So that works. And gonna look again. We see we have some 3s. A 4. Oh, interesting. We're not accounting. So I think I know what the issue is now. We're not accounting for the fact that multiple paths will trace back to the same 9. We're just counting unique paths, which like very well could be part 2 of this problem, which is kind of funny. It will be very funny if it is. But that means that we have to do something slightly trickier, which is interesting. Let's make that bigger again, so now we can see that. I can remove our debugging stuff here. I'm just going to commit this as a checkpoint, sort of get add dot day 10 part 1 not yet working. So that means we need to store something else in this, in each cell, and that we're taking the count of it. Which will break our debugging when we do this, but we want it to be a set of the coordinates of the 9s that can be reached from that spot. So instead, we change this to be set.new. I think takes an array, and we'll just put our nice coordinate pair in there. And then we don't want to sum here. We want to call set.new and set this to the union of all the. So we like this logic. How do we want to do this? Definitely not doing more than one puzzle today. Not just how slow I am today. I'll catch up more tomorrow. Just gonna mute myself for a sec here and go grab some water. I decided water and a gingerbread cookie. They're very good. They're my mom made them. She's very good at baking. So this one? No, not this one. I want pipe. What's union? Union pipe. Yeah. Oh, this doesn't need to say set.new here. I don't know. Is that right? So we iterate over all the neighbors. We map them. If the neighbor is one higher, then we take the set of coordinates that it can reach, set of peak coordinates it can reach. Otherwise, we return the empty set, and then we union all those sets together. I don't know. That seems right. Whoops, not gonna get commit. 482. That seems like a more. I like the sound of the answer better. Oh, and it's right. Yes. Okay. So we were correct in our assumption about what we were doing wrong, and our new solution works. Reindeer spend a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes, and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. A trailhead's rating is the number of distinct hiking trails which begin at that trail. Oh my god, it's the same. It's exactly what I said. Oh, I don't have my what was the number? 1095? Oh. 1094. 1094. Ha. Oh, come on. I have to wait 51 seconds. Well, while we're doing this, let's preemptively git rebase -I, and we want to reword this commit. And we want to change its git command to day 10 part 2, so that, oh, come on, 21 more seconds. I'm not even reading the puzzle. We already solved it. We our initial solution was actually just part 2. 4 more seconds. Can't expect me to count in my head. All right, amazing. Okay, so we did day 10 part 2 and then did day 10 part 1 by accident. Um, 10 out of 10. Go us. That's very funny. And we've rebased it. So that, how do you do that? -3. There we go. That's what I meant. We've rebased it to fix the commit messages so that our history correctly reflects what I was suspicious of, which is that we had accidentally solved part 2. So I've said many times, I'm really tired, so I'm not going to attempt another puzzle today. Thanks for coming out, Marco. I will be back on probably sometime tomorrow morning, if all goes well. See ya.